This is question 1 from the set of practice questions, looking at questions where asked to describe the operation of a pneumatic circuit. And the circuit we're given here is a circuit for control of a factory door. So the cylinder A is going to be pushing a piston which is responsible for opening and closing the door. And we've got to describe what's going to happen from the point where the air bleed is covered in this circuit. So I think it's important to start off by thinking about where air comes into a circuit like this. And all of the air supplies are indicated by this symbol here, so dot with a circle around it. This means air supply. So we can have a look where air is coming into the circuit just now. So up at valve 1, we have air coming in here. It's passing through the unidirectional restrictor, but because there's an air bleed, it's leaving the circuit at this point. At valve 2, we've got an air supply which can't progress through the valve currently. In valve 3, we've got an air supply that comes in here and will be causing the cylinder to have the piston in-stroked. And at valve 4, we have an air supply potentially coming in here, but again, it can't progress any further. So this is the state of things when we begin this problem. We don't have any air coming to any part of the circuit that's going to be doing anything. The cylinder begins in-stroked, and the air supply to the right-hand side, so that's going to keep it that way. So we're given our condition for things changing here. We're told the air bleed's going to be covered. So let's indicate this in our diagram. Now, when you're doing a question, it's absolutely fine for for you not to draw anything at all, unless, apart from it specifically says draw a component. When describing things, you can just draw a written description. So I'll write out over on the right-hand side here, the first line we're given. So when the air bleed is covered, first thing that will happen is we'll no longer have air coming out the top of the system. What we'll have instead of a signal, and a signal is sent to actuate valve 2. Now we want to be really specific. We can say that valve 2 is a 3-2 valve. Now what does this mean? Well, those two arrows at the top and bottom at the top of valve 2 are a diaphragm representing airflow, meaning that when air can flow through valve 1, and send a signal, or signals are given by dotted lines. We see a dotted line coming down to the top of valve 2, so that tells us it's going to be a signal. Signal sent to actuate valve 2, because air sent to the top of it's going to allow it to change state. So what we can say is valve 2 will change state. And that means that rather than the air supply being connected to this lower box in valve 2, I'll circle it briefly, we had the air here, what we're going to have is the upper box. So we're now going to have the air supply instead. Imagine this is sliding down, but the air supply coming in through the top. So the air supply is passing through valve 2 now. This is our 3-2 valve. It's changed state, and we're able to let air flow through it now. So valve 2 will change state, and this allows And this allows a signal to be sent to valve 3, because what's happening here is we've now got signal coming in on the left-hand side of valve 3, and the arrow indicates that this is pilot air, so even if valve 2 is only on briefly, it would be enough, but if it's kept actuated in the on state, that will of course keep valve 3 switched over. So what happens to valve 3 is, well, that's is, I should write it in here, this actuates valve 3, and I can say via pilot air. Now, when it comes to a model answer, I'm probably giving a bit more than we need to give. If you gave all these things, it's definitely enough, but probably giving a little bit more need to. This actuates valve 3 via pilot, causing it to change state. That's what's happening now. And when valve 3 changes state, well, if we take away all this air here, what's happening instead is, again, we're imagining that instead of having our air coming in here, we've changed over to the other box now. So instead we've got air coming through here, which if we slid that box across, we connect to this line, so we have air coming up here. It's going to go in the cylinder on the left hand side. We're also going to get air going off round this dotted line around the side. We'll come to that in a second, but let's deal with the air. So what we can see here, we can keep it simple. This supplies air to the right hand side of the cylinder, causing the piston to outstroke. So what we've got here is our piston is actually going to be over here somewhere now, because the air has been supplied to the right hand side. Now, of course, we don't need to write this, but for completeness, we also have air exhausting out of the valve like this. The blue colour we used to use because exhaust air. So all that air that was in the cylinder is going to be exhausted out the system, but we're not asked to say anything about that. So when we have a split like that just before the left-hand side cylinder, this is happening at the same time. So we're getting a signal sent around here. And what we've got is a unidirectional resistor, valve 7, and we've got a reservoir, called component, but a reservoir at number 6. So what we can say about this, I'll move our diagram down, we can say at the same time, because this is happening at the same time, the air goes to the cylinder, but at the same time, a signal, and remember we always call it a dotted line, it's a dotted line, we call it a signal. A signal is fed back to the time delay components. So remember, a unidirectional resistor in the direction that's being resisted, that's important, followed by a reservoir creates a time delay, because the air is of lower pressure coming through, and we have to wait until the reservoir has filled, and we can control on the unidirectional resistor how quickly the air will flow through. So the time to fill the reservoir will create a delay in our system. So we call 6 and 7. I'll quickly highlight this. I'll use green. This is our time delay, and here these two are highlighted in green. I just label that on. So there's no harm. I can write as much as I like. All these annotations you would need to do just what's written on the right hand side, but So at the same time, the signal is fed back to the time delay components. Great. We wait. After the delay, a signal is sent to actuate valve 3. And I might have mentioned it, I didn't mention this earlier, but I could have said that valve 3 is a 5-2 valve as well. Again, not every single, the really key points, the key points are about signals, valves being actuated, states changing, and pistons instroking and outstroking. These are the really important things to include in an answer. Including component names is definitely valuable, but if you didn't include every single component name, you'd still be able to get full marks for an answer. We do want to use technical language, but it is appropriate to refer to a valve as a valve. A signal sent to actuate valve 3, and you could say via the shuttle valve 5. I'll include that, but if you didn't say this, it would be fine as well. It's kind of implied from the diagram. Via valve 5, which is the shuttle valve. So let's draw on what's happening here. Well, after the time delay, so our reservoir fills up with air, and once it's full, we can send a signal down here. This will slide the ball across, and we'll get an air signal sent in to valve 3. So signal sent to actuate valve 3, and valve 3 changes state. And if we just bring down our diagram here, it's getting a bit messy now, but when valve 3 changes state, what's going to happen? Well, when it changes state, it's going to shift back to the original setup. Again, we shift back to the original setup here, and what will happen is that air is now flowing in this side again. If we switch back onto this box, the air is coming in this way, the air is going to be exhausted out this way, and it's going to cause the piston to instroke. I'm not going to say all that, we've kind of said a bit about that already. We can just simply say valve 3 changes state. You could say supplying air to the right hand side, but I'm just going to say here causing the piston to instroke. And that's us almost done. One final thing to say, and I'll tidy this up again, which is alternatively, if valve 4 is actuated and changes state, a signal would be sent to valve 3 as above, also causing piston to instroke. So what would happen here? Well, what we're saying in this last little bit, this last little section here, is while we are waiting for that air to come round and fill the reservoir, instead, if we press the push button, we could have air coming in here, and that instead would send the same signal that we're waiting for to switch valve 3 back across and let the air go into the right of the cylinder. So in this circuit, we can close the air bleed and it will follow through the process. The cylinder will outstroke And while it's outstroking, some air will be sent round the time delay, and when that delay is over, it will switch the 5-2 valve, that's valve 3, back across, and it causes an in-stroke. If we want to skip that delay, if we press the push button in valve 4, if we press this button here, then we can just send air straight to valve 3, causing the in-stroke to happen faster. So for full marks in a question like this, you would need to talk about valve 4. Most of the marks for just explaining system, but valve 4 is here for a purpose, which means that we have to talk about it as well. So that's the answer you'd expect to give. I would say that's about 4 paragraphs. You'd probably get away with 3 because some of the things I've done are really spelled out, but that definitely would be an answer that would achieve full marks in a similar TMA question.